All right, let's dive right into this explainer. Have you ever actually stopped to wonder why almost every animal with a backbone, whether that's a fish, a bird, a lizard, or a human being, has exactly two eyes? We're going to break down the evolutionary logic behind this binary blueprint staring back at us in the mirror and figure out why a pair of eyes is essentially the biological Goldilocks number.
So is having exactly two eyes just some random coincidence, or is it a mathematically perfect survival strategy? I mean, think about it. Why not just one eye, like a mythical cyclops? Or why not 4, 5, or 8 eyes like some spiders? As we'll see today, this two-eye design isn't just about letting light into your brain. It is a highly calibrated piece of biological machinery that is largely responsible for putting humans at the very top of the food chain.
To prove just how crucial this machinery actually is, try this quick experiment with me right now. Close one eye, hold up a pen in one hand, and then try to touch the tip of that pen with your other index finger. You're probably going to miss, or at least hesitate for a second. And this brilliantly illustrates our core premise. Seeing the world effectively is about way more than just registering light. It's about distance, it's about math, and ultimately, it's about survival.
To understand our very first evolutionary superpower, we gotta ask how our brain actually builds the physical world around us. Because what your left eye sees and what your right eye sees are actually two totally separate, flat, two-dimensional pictures. So how do those two distinct streams of data magically transform into the rich, 3D reality we experience every single waking second?
The secret here is a little something called stereopsis. Because your eyes are set a few centimeters apart on your face, they each capture the world from a slightly different angle. And your brain does this incredible trick where it takes those two flat images and merges them into one single 3D cyclopean view. This depth perception is the ultimate survival tool. Without it, the world would just look like a flat painting. Stereopsis is exactly what tells you precisely how far away a predator is, or exactly how far you need to reach to grab your coffee.
Let's actually peek inside the brain to trace this processing pathway. The visual data first hits an area called the V1 visual cortex. And here's the wild part. In V1, your brain is essentially still seeing double. It's processing two totally separate streams of flat images. But by the time that data travels just a tiny bit further to the V2 visual cortex, boom, your brain has completely united the images. V2 is where that single, useful 3D picture gets finalized, so you can aim your hand or foot with total mathematical precision.
Section 1. The Predator versus Prey Game. Now, looking at this breakdown, there's a really fascinating evolutionary dichotomy going on here. Look at predators like us, owls, or lions. Our eyes are front-facing because we absolutely require extreme depth perception to hunt and to know exactly when to pounce. But the trade-off, we have terrible peripheral vision. Something could totally sneak up behind us. On the flip side, prey animals like rabbits, deer, and horses have side-facing eyes. They don't need to see deep. They just need a massive 360-degree field of view to spot movement and bolt. Their fields of view barely even overlap, which means they're quite literally seeing two different worlds at once just to stay alive.
So, okay, depth perception and field of view totally makes sense. But what if I told you that having a pair of eyes actually unlocks some incredibly unexpected secondary abilities? Things that sound basically like science fiction. Like, can having exactly two eyes really give you night vision or let you see through solid obstacles? The answer is a resounding yes. It all comes down to a really cool concept called binocular summation. When you're in the dark, your brain actually takes the visual noise from both eyes and averages it out. The mathematical result of this summation is that faint lights actually seem brighter and significantly clearer than they would if you were just relying on a single eye. Basically, your two eyes team up to act as a massive built-in light booster in the dark.
To see how these unexpected upgrades play out in the wild, just look at nocturnal animals like the New Zealand kakapo parrot. They evolved front-facing eyes specifically to get that light sensitivity boost to navigate the dark forest floor. And what about seeing through obstacles? Well, because your eyes are separated, you have a sort of built-in X-ray vision. If you hold a finger right in front of your nose, you can still see the room behind it because each eye sees around the finger. The stalk-eyed fly takes this to the absolute extreme, using its widely separated eyes to literally look around and through dense jungle leaves. It's wild.
Section 2. Why not 3 or 4 eyes? There's an evolutionary maxim that goes, evolution is a minimalist. It chooses the system that does the most work for the least amount of energy. And the biological reality here is that eyes are incredibly expensive organs to grow. Maintaining them takes a ton of physical energy, and processing the dense visual data they pull in requires a massive chunk of your brain power. Evolution definitely does not like to waste energy.
So the crucial point is really a balancing act between redundancy and energy cost. Having 2 eyes is perfect because it gives us a backup. If we lose one eye, we can still function remarkably well, which is a massive survival win. But a 3rd eye? That would give us severely diminishing returns. Think about it. A 3rd eye on the back of your head wouldn't give you much extra visual info that you couldn't easily and cheaply get by simply turning your neck. The energy cost of that 3rd eye just simply isn't worth it.
Okay, so we know 2 eyes are the perfect balance of function and energy. But where did this specific blueprint actually come from? Why do totally different species, from birds to humans to fish, all share this exact same layout? Well, let's take a quick look at biological history to understand why almost every vertebrate uses this specific design. It all ties back to homology. This is a shared trait inherited from a common ancestor. Hundreds of millions of years ago, our very first vertebrate grandparent had 2 eyes. Much like having 5 fingers at the end of our limbs, having 2 eyes was a blueprint that just worked beautifully for that ancient ancestor. It was so incredibly effective, in fact, that the rest of the vertebrate family tree simply kept the design. We inherited it.
But here is where the story gets really, really wild. If we inherited this trait, what happens when nature is forced to invent eyes completely independently? Like, without relying on that ancient vertebrate grandparent's blueprint at all. To truly blow your mind, let's look at what nature does when it has to start completely from scratch.
This brings us to a phenomenon known as convergent evolution. This is when nature independently evolves a remarkably similar trait twice in completely separate branches of the tree of life. Turns out nature is so incredibly fond of the 2-eye setup, and it's such an optimal solution for navigating the physical world that the evolutionary process actually built it from scratch a second time. Seriously, just compare the human eye with the octopus eye. An octopus is an invertebrate. It obviously didn't get its eyes from our vertebrate grandparent, and yet it uses the exact same lens, retina, and 2-eye setup as us. But here is the fascinating twist. Because the octopus version evolved completely separately, it's actually technically better designed. You see, the human retina is built inside out, which creates a built-in blind spot right where the optic nerve attaches. But the octopus eye, it's built right side out, meaning they have the exact same amazing binary vision as us, but with absolutely no blind spot.
So the next time you look in the mirror, remember that you aren't just looking. You are actively utilizing a high-speed distance calculator, a night vision booster, and a redundant survival kit, all wrapped up into one perfectly energy-efficient package. Your 2 eyes are the result of millions of years of life or death testing. Which leaves us with one final, fascinating thought to chew on. If a feature as simple as having 2 eyes holds this much hidden biological genius, what other evolutionary secrets are hiding right there on your face? Keep asking questions, keep exploring, and thanks for joining me on this explainer.